We're going to look at reading graphs in the rectangular coordinate system. So first we're going to look at just being able to interpret graphs, and then we'll actually take a look at the coordinates. So first, reading this graph, read the title first. It says the number of gamers per top 5 countries. Across the x-axis, across the bottom, we have countries given. Countries is labeled, and we have China, United States, Japan, South Korea, and Germany. And then the y-axis is labeled with number of gamers in millions. This information there is very important because when you read the increments, goes 100, 200, 300, so that means 100 million, 200 million, and so on. So you're not reading as like, oh, there's 100 gamers in this country, there's 100 million. First question, find the country that has the most gamers and approximate the number of gamers. That would be the highest bar, which would be right here, so that would be China. And we want to approximate, this isn't the greatest bar graph because it doesn't tell us 700. Usually it would tell you 600, and then if this next bar doesn't get to the 700, but they'd still tell you like here's 700, so in that way you would know like is it close to 700, is it far away from 700. So based off of this, I'd say we're probably closer to 700 than not, so I've just approximated as 670 million. Not looking for extreme precision or anything. Number 2, how many more gamers are in the United States than Japan? So we read United States is here, Japan is here. How high is the bar for United States? It looks like it's about maybe 250, we'd call it. Again, just approximation. So 250 mil for US. And then Japan has, let's say about, I think I kind of went up there. Say about maybe 75. I think my first line was a little bit kind of pulling up. So 75. So we want to know how many more are in the US than Japan. So 250 minus 75 is going to give us 175 more in the US. Yeah, that first bar, or that first line when I'm trying to figure out where it was, I think I started going up a little bit. Yeah, okay. Next graph, we have the amount of a drug in the bloodstream over 10 hours. So we have this graph, so read it over first and make sure you understand all the information. Across the x-axis is time, so 0 hours, 2 hours, and then the y-axis we have amount of drug in bloodstream in milligrams. So at 0 hours we have 0 milligrams of the drug, and then after 2 hours we have 60 milligrams of the drug. So the starting point was probably at 0 hours, the shot was given, and then the amount was increased over the 2 hours, and then it started to drop. Okay, so now we have an understanding of what this graph is saying, what it is representing. Let's now answer the questions. Number 3, how many milligrams are in the bloodstream after 6 hours? So after 6 hours is here, we just read, and then we go over to the y-axis, that would be 40 milligrams. 4, when is the change in the amount in the bloodstream the greatest? So when is there a biggest change from 0, and I'd call that 1 hour. It goes from 0 to 1 hour, there's a 50 milligram change. So that would be the biggest change. So 0 hours to 1 hour, biggest change. And then after that, it's pretty gradual of a decrease. But here it goes, it spikes up 50, so we'd say that they're probably being administered the drug at that time. A lot of it in the first hour, and then 10 more milliliters in the second hour, and then it just decreases down. So that's reading graphs, being able to interpret graphs, reading, understand them. Next, I want to look at the coordinate system, understand how to plot points. So when we have the coordinate system, here's off to the right there, that grid, that's the coordinate plane. We have 4 quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We use Roman numerals when we're identifying the quadrants. When you're in a certain quadrant, it's good to know what the signs are going to be. Like, is it positive? Is it negative? What X and Y's? So we have ordered pairs of being X and Y. So depending on where you're at in the quadrant, in the grid here, your signs will indicate where you're at. So for example, if I am in the first quadrant, I have a positive X value and a positive Y value, because if I'm at the origin of 0, 0, and I go over X and up Y, I am in this first quadrant, which means I went positive X, positive Y. If I'm in quadrant 2, so that means I'm over here in quadrant 2, in this part of the graph, I have a negative X value, because we had to go on the left side of the X values here, and then we have a positive Y value, because I had to go up the x-axis there. If I'm in the third quadrant, so that would be going negative x's and also the negative y's to get me in that third quadrant, I'm going to be negative negative. So negative x, negative y. Now if I'm in the fourth quadrant, I went in the positive x direction, but I went in the negative y direction, putting me in the fourth quadrant. So that would be positive x and negative y. So let's actually plot ordered pairs. First one, 3, 6. So 3, 6, let me erase this stuff here. Don't want too much stuff on my grid. So 3, 6, so positive 3, positive 6. My x value is positive 3, my y value is positive 6. So I go on the x-axis to 3, and then I have to go, so I'm right here, looking right here. X-axis is positive 3, and then I go to the y value of 6, so 3, 6. And I just put a point. I'm just gonna I'll just label 3, 6. Common mistake with plotting order pairs is this. You'll see the order pair 3, 6 and do this. You'll put, all right, I'm at 3, and then you put a point at 6. So you have like these 2 points. The order pair doesn't indicate 2 points. It indicates one single point at the point 3, 6. So you don't put a point at x equals 3 and then go to 3, 6. You don't do that. You could navigate yourself to using that. Like, okay, I'm here, and then I go up, and then make sure you don't actually indicate that. Like, don't actually draw that in. Like, just take your pencil over your paper and say, I'm here, and then I go up 6. Number 6, negative 2, 3. So I'm in the negative x value, so negative 2. So I'm here, and then my y value is positive 3. So negative 2, 3 would be right here. Number 7, 1, negative 2. So I'm in the x value of positive 1, y value of negative 2. So I went 1, negative 2. That would be 1, negative 2. Number 8, 0, negative 3. So the x value is 0. A lot of people get a little bit mixed up when 0 makes its appearance when we're plotting points. The x value is 0. That means I'm not going left, I'm not going right. I'm staying right here. Right on the y-axis is where I'm staying. But I want to go y equals negative 3, so that means I'm going to go down to negative 3, meaning my ordered pair is 0, negative 3. Right there. I just had to stay on the... I did not move anywhere on the x-axis, so I stayed right here on the y-axis going down. 2, 0. Same discussion, but this time we're going on the x-axis of 2. So I'm here, but then my y value is 0, so I'm not going up or down this time. I'm staying within the x-axis, so I'm either going left or right, but not going up or down. And in this case, I went right to 2, 0, so that'd be right here, so 2, 0. 0, 0, I already talked about this. 0, 0 is just the origin. It's right here in the middle. And last point, negative 4, 3. So I'm going to go x at value negative 4. So I'm here. Remember, we don't actually put a point. And then I'm going to go y value negative 3. So negative 4, negative 3 right here. Okay, so that's just good practice plotting points. Now we need to look at determining whether each ordered pair is a solution to the given equation. So in a little bit, we're going to get to a point where we're graphing lines, and then we have to understand what that line means and what we can take from that line. So these ordered pairs are given, and what we want to know is this a solution? Meaning, if I were to graph this line on a grid, if I were to graph 3y plus y equals 6, it looks something like this. Something like that. I'll do that. What I want to know is, do these ordered pairs fall on this line somewhere? Are those ordered pairs on that line? That's what we're trying to decide. So we want to take these ordered pairs, and we want to plug them into this equation and see if we get a true statement or not. So the first one, the x value is 1, the y value is 3. So I'm going to do 3 times 1 plus the y value of 3 equal to 6. I'm just replacing x and y with 3 and 1. My x value being 1, my y value being 3. 3 times 1 is 3, plus 3 equal to 6. 3 plus 3 is 6, equal to 6. That is a true statement. So we'd say yes, that is a solution to the given equation. Letter B, 0, negative 1. My x value is 0. My y value is negative 1. So for the x value, I plug in 0. 3 times 0 plus negative 1 equal to 6. 3 times 0 is 0 plus negative 1 equal to 6. 0 plus negative 1 is negative 1 equal to 6. That does not equal, so we'd say no. 3, negative 3 equal to 6. So 3 times 3, because it's 3x, plus negative 3 equal to 6. 3 times 3 is 9, plus negative 3 equal to 6. 9 minus 3 is 6. 9 plus negative 3 is 6. 6 equals 6? Yes. So that would be a point. So what this translates so far is that this first point, 1, 3, that's on the line. This point, 3, negative 3, that's on the line. This point was not, though. But letter D, let's see if this point is on the line. Negative 1/3, 5. So the x value is negative 1/3. So we have 3 times negative 1/3, because my 3x, plus the y value of 5 equals 6. 3 times negative 1/3 is going to be just negative 1, right? Because the 3's cancel. So I get negative 1 plus 5 equal to 6. It's close, but not quite. Negative 1 plus 5 is 4, because it's 5 minus 1. 4 does not equal 6, so no to that one. So we have 2 of those points that are falling on the line. Next, complete the table for the equation y equals negative 3x. We have a table here with some x values and some y values given. So we want to get these corresponding missing points, because then what's going to happen is we're going to get an ordered pair. Like these x and y's are going to create an ordered pair, which we just practiced plotting ordered pairs. So we'd plot those ordered pairs and we would get a graph of an equation. So the x value here is negative 1. So that means for this equation here, y equals negative 3x, I'm going to replace x with negative 1. So y equals negative 3 times negative 1. So y equals negative 3 times negative 1 is positive 3. So my ordered pair would end up being negative 1, positive 3. I'm using negative 1 because that was my x value given. So x is negative 1, y value is 3 because that's what we got as a result. Next one, the y value is 0. So I'm replacing y with 0. So 0 equals negative 3x. And I'm solving for x this time. So pay attention to what we're given. Are we given x or y? And here I'm given y. So I'm going to divide by negative 3. So x is equal to 0. So that ordered pair is going to be 0, 0. And then, again, y is equal to 9. So we're going to say 9 is equal to negative 3x. And I'm going to divide by negative 3. X equals 9 divided by negative 3 is negative 3. So that ordered pair is going to be negative 3, 9. And then I put x equal to 0 just to make sure that we get the consistent answer here. X equal to 0, same thing's going to happen. Say y equals negative 3 times 0. Negative 3 times 0 is 0, so negative 3, negative 3 times 0 is 0, so we get y is equal to 0. So we get 0, 0 again. I know we already did that, but I wanted to throw that one on there just so you see the differences between y is equal to 0 and x equal to 0 and the process that changes, but it's going to be the same ordered pair in this case. Now, it was going to happen like that, but in this case it did. Let's take a look at another table. Y equals negative 1/2 x minus 3. So we're given some x and y. So let's see what happens. So the x value of negative 2. I'm going to go over here. So a little bit more room to write. Y equals negative 1/2 times negative 2 minus 3. So negative 1 times negative 1/2 times negative 2. 2's are going to cancel, giving us negative times a negative, which is a positive 1 minus 3. 1 minus 3 is negative 2. So we get negative 2 as our y value, ordered pair, negative 2, negative 2. Let's plug in 0. Y equals negative 1/2 times 0 minus 3. Negative 1/2 times 0 is 0. 0 minus 3 is negative 3. So that ordered pair is going to be 0, negative 3. And I did it again, where if you look at y is equal to 0, notice when we had x equal to 0, we got negative 3. So it's not just going to translate itself back to the exact same thing like how we did in that last one. So we do have to evaluate when y is equal to 0 just to get an understanding what that's going to look like. But let's do y is equal to 5 this time. So y is equal to 5. I'm going to say 5 is equal to negative 1/2 x minus 3. I'm going to add 3 to both sides here because I want to solve for x. 5 plus 3 is 8. equals negative x over 2. So I'm going to multiply. I'm going to knock out 2 steps here. I'm going to multiply by negative 2 because I want to get rid of that negative and that 2. So I'm going to multiply by negative 2, giving me x is equal to negative 16. So the x value here is negative 16. We can go ahead and write an ordered pair being negative 16, 5. Move this down a little bit. And last one, y is equal to 0. So I'm going to say 0 is equal to negative 1/2 x minus 3. I'm going to add 3 over to both sides. 0 plus 3 is 3 equals negative x over 2. Same thing that we did in the last one. I'm going to knock out 2 steps in one. I'm going to multiply by negative 2. So I get x equals negative 6. So those are all of our ordered pairs. Good practice there. And last problem I have here today, we have an application to this. A computer was purchased for $2,500. A 5-year projection model projects the value of the computer can be modeled by this equation. So we have an equation that's going to show us the value of this computer over a 5-year projection. So what we want to do is we want to fill in these gaps with the value. So at x equal to 0, where x is the number of years, and then y is going to be that value of the computer. So x equal to 0 meaning 0 years. So if we do x equal to 0, that's going to be negative 200 times 0 plus 2,500. Negative 200 times 0 is 0. 0 plus 2,500 is 2,500. So the computer at 0 years is valued at $2,500. That makes sense because we purchased it for $2,500. Okay, cool. Checks out. Next, negative 200 times 1 plus 2,500. Negative 200 times 1 is negative 200 plus 2,500. 2,500 minus 200 is 2,300. 2 years. Negative 200 times 2 plus 2,500. Negative 200 times 2, negative 400 plus 2,500. 2,500 minus 400 is 2,100. And if you're seeing the pattern here, I would just fill in the rest. But if you're not quite, I would just go to my calculator and I would do negative 200. Like I wouldn't even write it out at this point. Negative 200 times 3 plus 2,500 is 1,900. Seeing a pattern yet? 4 years. Negative 200 times 4 plus 2,500 is 1,700. And if you're not seeing it yet, I'm just going to spoil it for you. Each year we're decreasing by $200. So this one's going to be 1,500. Why is it decreasing by $200 every year? What in the equation is indicating this $200 change per year? Right here. Negative 200 times x. This is called the slope, and I know we haven't discussed that yet, but that's the slope of this line. If we were to graph this line, that would be the slope, and that would tell us our change in this information. How much is it changing by for every x value? It's changing by $200 for every x value, and in this case, it's decreasing by $200 for every year, x values being the year. So for every year it goes by, that computer is losing $200 worth of value. Good application to order pairs.